Hi students, I'm Tanveer Malik. Today we will start unit number 2 and this unit is about sound. This is the second class about sound. In first class we have discussed about how sound is produced, how sound is traveled from one place to another place, and what are the main characteristics of sound. Today we will start what is echo, why echo is produced, how sound is reflected from the other surface. Why in some buildings echo is produced while in some buildings echo is not produced? What is the minimum distance required for echo? So we will start. What is echo? When we clap or shout near a reflecting surface, such as tall building or a mountain, we hear the same sound again a little later. This is called, when we hear the same sound after short time, this is called echo. The sound which we hear is called echo and is result of reflection of sound from the surface. Basically, sound wave when strike with the surface, strike with the building, it bounces back since sound is a wave. And reflection is the property of wave. When sound waves strike with the tall building or mountain, then it bounces back, and this bouncing back of a sound after some time, this is called echo or reflection. When sound is incident on a surface of other medium, it bounces back into the first medium. This phenomena is called echo or reflection of sound. This is basically echo when sound is bounced back in the same medium. Echo production. These are the sound waves which are emitting from the mouth, and when these sound waves strike with the wall, all these sound waves will bounce back and the person will hear the same sound after some time. First waves which are going towards the wall, and these waves are shown by a dotted line, whereas when these waves strike with the walls and these bounce back and the same person hear the same sound after some time, this is called echo or reflection of sound. Minimum distance required for echo. For hearing distant echoes, the minimum distance of the obstacle from the sound must be half of its distance, that is 17 meters. This is the minimum distance which is required for echo. If distance is less than 17 meters, then a person will unable to hear that sound and no echo will be heard. Effect of sound on our brain. Reason is this: the sensation of sound persists in our brain for about 0.1 second. That means when I talk, its effect will remain on my brain equal to 1/10 second. To hear the clear echo, the time interval between our sound and the reflected sound must be at least 0.1 second. Sound waves are going, and when these sound waves strike with the wall and these sound bounce back, the time for bouncing back of sound waves must be greater than 0.1 second. If this time is less than 0.1 second, then these sound waves will merge in the first waves and we are unable to hear a separate sound. But when the distance is large and sound waves are going in forward direction, these sound waves will strike with the walls and these sound waves will bounce back, and these sound waves take more than 0.1 second, then we will hear a separate sound. When a person talks or when we hear a sound, its effect remain on our brain will be 0.1 second. And when the sound takes more than 0.1 second, then we are able to hear that sound separately and that sound will not merge in first sound. If we consider speed of sound to be 340 meters per second at a normal temperature in air, then we hear echo after 0.1 second. Total distance traveled by the sound from point of generation to the reflected surface and back should be at least 340 multiplied by 0.1 second. Since we know that speed of sound is 340 meter per second, and formula for speed of sound is V equal to distance divided by time. Now here sound waves are traveling double distance. First sound will move towards the wall, towards the building, then sound waves will bounce back, and these sound waves will travel double distance. So instead of D, we will take 2D divided by time, and speed of sound in air, that is equal to 340 meter per second. In air, this is equal to 340 meter per second, and 2D. Now we are calculating the distance, minimum distance for echo. Time, that is 0.1 second. The time duration due to which sound persists on our brain, that is 1 by 10 second. So instead of time, we will write 1 by 10 or 0.1 second. When a person hear or listen a sound, its effect on our brain is equal to 0.1 second. So formula for speed is V equal to 2D over T. Velocity of sound in air is 340 meter per second. Distance 2D. Why we taken distance as a 2D? Since one sound wave will travel in forward direction, and when these sound waves will strike with the walls, these sound waves will bounce back, and these sound waves will have to travel double distance. So instead of D, I taken as 2D. And time which sound will persist on our brain, that is 1 by 10 seconds. Now we will calculate it. 340 multiplied by 1 by 10 equal to 2D. 0 will be cancelled. 340 equal to 2D, or D equal to 34 divided by 2, that is equal to 17 meter. This is the minimum distance which is required in order to hear a clear echo. If the distance is less than this minimum distance, then we are unable to hear a separate sound, and that sound will be mixed in the first sound. So 17 meter, that is the constant for hearing a echo in air. If the distance is minimum 17 meter, then we are unable to hear that sound. Then we are unable to hear a separate sound. But if the distance is more than 17 meter, then we will hear that sound separately, and that sound which we hear separately, that is called echo. More than one echo. Sometimes we hear more than one echo. Echo may be heard more than once due to successive or multiple reflection. When a sound wave is traveling in forward direction, strike with the wall and bounce back and strike with this wall. Then again it moves in forward direction, and we hear multiple echoes. And these multiple echoes are here in a big hall. Sound waves are spreading in all directions. Some sound waves are traveling in forward direction. Some sound waves are traveling in leftward. Some sound waves are traveling in rightward. All these sound waves are reflecting, and we hear multiple echoes. For example, front distance, that is equal to 18 meter. And on leftward, that distance is suppose 20 meter. Then the distance which is 18 meter, sound wave when strike with the front wall, it bounce back in less time. And the wave which is going to the left side and distance is 20 meter, that sound wave will reach in our ear slightly more time. It will take more time. So we hear again echo, and the sound wave which is traveling towards the right, and its distance is supposed 25 meter. The sound wave when bounce back from the right wall, it will reach in our ear in more time. So we will hear multiple echoes. due to difference in distance of the obstacle. Next is where these echoes are applied. Echoes are applied to measure the depth of sea. When we want to measure the depth of sea, we send sound waves with the help of ship. And when these sound waves strike with the bed of the sea, these sound waves will bounce back. We know the frequency of these sound waves. We measure the time. Then we can calculate the distance of bed from the sea. And this is called sound navigation and ranging. This is called sonar, sound navigation and ranging. By using sonar, we can measure the depth of sea bed. Sound waves are echoes are used by different animals in order to search their prey. Some animals emit sound waves, and when these sound waves strike with the prey, these sound waves will bounce back, and that animal will detect the distance of prey from him and easily catch that prey. Similarly, whale also use sound waves. Sound waves from the whale, a song is reflected in echo and travels back to the whale. In this way, it can detect its prey and it can detect its distance of the prey and easily catch that prey. Examination style questions about echo. Question number 1. Determine the appropriate value below the speed of sound in water. 4 options are given. What is the value of speed of sound in water? 1.5 meter per second? No. 15 meter per second? No. 150? No. 1500 meter per second. That is the correct option. So speed of sound in water is 1500 meter per second. That is the correct option. (1500 meter per second). Sound travels in water as a series of compression and rarefaction. Determine what is meant by compression and rarefaction. In types of waves, we have discussed in detail that there are 2 types of mechanical waves. One is transverse wave. Second is longitudinal waves. In longitudinal waves, disturbance travel from one place to another in the form of compression and rarefactions. Compressions are those regions where particle of the medium become close. Particle of medium, distance between particle of the medium decreases. These points are called compression. Compressions are those regions in medium where particles of medium are very close with each other. Compressions are those regions where particles of medium become close with each other. These regions are called compression. Our distance between the particles of the medium decreases. These regions are called compression. And rarefaction are opposite, are those regions where particle of medium become far apart. Instead of close, you will write far apart. So rarefaction are regions where particles of medium become far apart with each other. Rarefactions are those regions where particle of medium become far apart with each other. These are called rarefaction. Next question. An echo sounder sends out pulse of sound to determine the depth of seabed by measuring time between sending out pulse and receiving its echo. Figure shows both sending and echo sender. Seabed is shown and its distance is 12 meter. Seabed is 12 meter. Echo sender, use your value in speed of sound from A. That's mean 1500 meter per second. This is the speed of sound in water, which is constant, 1500 meter per second. To calculate the time between sending out of the pulse and receiving its echo, you have to find the time. Same formula, V equal to 2D over V. You will use this formula. Why we have used 2D? Since one sound wave will go, this pulse is going towards the seabed. When it strikes with the seabed, it bounces back. It is bouncing back from the seabed. So we have to use double distance. This is first distance and this is second distance. So we have to use that distance, double distance we will use. So V equal to 2D over T. Velocity, we have to use 1500 meter per second, which is in the first part. And it is also constant. Sometimes it is not given. 1500, 2D, distance is given, which is 12 multiplied by 2. 2D. We have to multiply distance with 2. D over T. Since we have to find the time, so time will become 1500 equal to 24 divided by time, or time equal to 24 divided by 1500. So this will be equal to 0.16 second. This is the time which will be taken by the sound wave to bounce back from the seabed. So you will use the formula of velocity. Formula for velocity is V is equal to D over T. But here we have used V equal to 2D over T. Why we have used 2D? Since one sound wave will go downward, then it will bounce back from the seabed. So distance will be taken double. V is given, or it is constant quantity, you have to memorize. V equal to 1500, 2D is 12, which is given in the question. This is the D. And time you have to calculate. So 1500 equal to 24 divided by time, or T equal to 24 divided by 1500, that is 0.16 second. Next is, figure shows dolphin in water emitting a sound wave of frequency 95 kilohertz. Frequency is given. Calculate the wavelength of sound. Same formula. Relationship between velocity and frequency. We know that V equal to F lambda. Lambda is called wavelength. You have to find the wavelength. Velocity is in water, that is 1500. Frequency is given 95 kilohertz. You have to convert kilohertz into hertz. 95 kilohertz. You have to convert 95 thousand. That is hertz. Now kilohertz is converted into hertz. So instead of F, we will use 95,000 into lambda, or lambda equal to 1500 divided by 95,000. So wavelength will be equal to 0.157 meter, or 15.7 centimeter. This is the wavelength. In this question, you have used V equal to F lambda, where V is the velocity, F is the frequency which is given in the question, and you have to calculate the wavelength. Next question. Figure shows the path of speed sound wave from a source X. Here, a source X is placed, path of sound wave, and when it strikes with the wall, here the listener is standing at point Y. State why the person standing at point Y near to the here to echo. Why he is standing here? Why? Why is not standing here? Why is not standing here? Since sound is a wave and it obeys laws of reflection, angle of incidence must be equal to angle of reflection. So when a sound wave will strike, if we draw perpendicular here, when we draw a perpendicular at this point, this is the angle of incidence. So sound wave will bounce back with the same angle. Angle of incidence and angle of reflection must be equal. For this reason, person is standing at point Y. So you will write its answer. Since sound is a wave, it obeys. Sound is wave. It obeys laws of reflection. Or you can write angle of incidence must be equal to angle of reflection. Only if you write, since angle of incidence and reflection must be equal, so here angle of reflection is equal to angle of incidence. Or you can write angle of incidence equal to angle of reflection. So person is standing at point Y in order to hear the sound. Frequency of sound wave leaving X is 400 Hertz. State the frequency of the sound wave at point Y. There is no change in frequency. When a sound wave is reflected back, there is no change in frequency. So frequency will be 400 Hertz at point Y. Next, C part, speed of sound wave leaving at X is 330 meter per second. This is the speed. Calculate the wavelength of these sounds. V is given. You will use the formula V equal to F lambda. V is 330 meter per second. Frequency is given in the above part, 400. Lambda you have to calculate. So lambda will be 330 divided by 400, and it will be equal to 0.825 meter. This is the wavelength, lambda. Sound waves are longitudinal waves. State what is meant by the term longitudinal. There are two types of waves, transverse wave and longitudinal. Longitudinal waves are such type of wave in which particle of medium vibrate parallel to the direction of motion of wave. Longitudinal waves, in longitudinal waves, particles of medium move parallel to wave. So these are longitudinal waves. But if the question is asked, what is meant by transverse wave? In transverse wave, particle of medium vibrate perpendicular to the direction of propagation of wave. So this is called echo, that is completed. Thank you.